Ladakh's sky turned blood red. It wasn't just beautiful, it was a warning. For those who have stood beneath the skies of Hanle in Ladakh, silence is the first thing you notice. The darkness there is deep and unbroken, so pure that stars do not shimmer but burn steadily against a well-wet black canvas. Astronomers travel thousands of kilometers to witness nights like these. On January 19th and 20th, that familiar calm shattered. Instead of darkness, the sky above Hanle glowed a deep, unsettling crimson. It was not a soft hue or a fleeting shimmer, but a vivid blood-red light that seemed entirely out of place. Images spread rapidly across social media, celebrated as a rare appearance of the northern lights over India. The spectacle was undeniably breathtaking, but behind the beauty lay a far more serious reality. What illuminated Ladakh was the most intense solar radiation storm witnessed since 2003, a reminder that the sun, the source of life on Earth, can also be a powerful threat. A day earlier, on 18th January, the sun unleashed a violent X-class solar flare, the strongest category of solar explosion. The flare propelled a massive coronal mass ejection, CME, into space, a dense cloud of superheated plasma threaded with magnetic fields. Traveling at nearly 1,700 kilometers per second, the CME reached Earth in just about 25 hours. When it struck, Earth's magnetic shield absorbed a direct hit. The collision triggered a G4-level geomagnetic storm, officially classified as severe. Charged solar particles flooded the magnetosphere and excited oxygen atoms more than 300 kilometers above Earth's surface. At such extreme altitudes, oxygen emits red light, creating the rare auroral glow visible over Ladakh. Auroras are typically confined to polar regions, where Earth's magnetic field funnels solar particles toward the poles. Hanle, far south of these regions, witnessed only the upper fringe of the auroral display, and that fringe burns red. Scientists say this was the sixth such intense red aurora observed at Hanle during the current solar cycle. While the sky offered a stunning visual display, instruments in space recorded a far more troubling picture. The storm was categorized as an S4-level radiation event, indicating a dangerous surge of high-energy protons. Data from India's Aditya L1 mission revealed that Earth's magnetosphere was compressed alarmingly close to the planet. For brief periods, even geostationary satellites, critical for communication, weather monitoring and navigation, were exposed directly to harsh solar winds. The impact was serious enough that astronauts aboard the International Space Station were instructed to move into shielded areas as radiation levels spiked. Such storms pose real risks to modern civilization. Strong geomagnetic activity can induce powerful electric currents in power grids, damaging transformers and triggering widespread blackouts. It can disrupt GPS systems, aviation navigation, internet connectivity, and digital banking networks. Satellites may experience orbital drag as Earth's upper atmosphere heats and expands, potentially shortening their operational life or pulling them out of orbit entirely. For a country like India, rapidly digitizing and increasingly dependent on satellite infrastructure, the consequences of extreme space weather are not abstract concerns, they are immediate vulnerabilities. The difference between a spectacular event and a catastrophic one often comes down to warning time. India's Aditya L1 spacecraft, positioned at the L1 Lagrange point nearly 1.5 million kilometers from Earth, plays a crucial role in this defense. By monitoring solar activity continuously, it can detect incoming CMEs 1 to 2 days before impact. This early warning allows satellite operators to activate protective measures, power grid managers to adjust loads, and aviation authorities to take precautionary steps. On the ground, India's astronomical facilities also play a vital role. The Indian Astronomical Observatory at Hanle, located within the Hanle Dark Sky Reserve, provides critical observational data that complements space-based measurements. However, this capability depends on preserving the region's pristine darkness. Hanle is India's first officially recognized dark sky sanctuary. Increasing tourism and artificial lighting threaten to erode this darkness. If that happens, the loss will extend beyond aesthetics. It will compromise a key window into monitoring space weather and understanding how solar activity affects Earth. Scientists warn that events like the January storm may become more frequent. The Sun is approaching solar maximum, the most active phase of its roughly 11-year cycle. Solar cycle 25 has already proven more aggressive than earlier predictions, with a rise in powerful flares and geomagnetic disturbances. The blood-red sky over Ladakh was undeniably beautiful. But it was also a message written in light. As the Sun enters a restless phase, Earth's technology-driven world stands exposed beneath it. The glow faded within hours, but the warning it carried remains, a reminder that the systems powering modern life are vulnerable to forces far beyond our atmosphere.